So just to set the scene a little bit for AR and what we're talking about, just so we know explicitly what I'm going to talk about tonight. AR is a big field and there's lots of different things going on. You're probably most familiar with AR Kit and AR Core, which is the handheld or mobile-based AR. But of course, there's HoloLens, Magic Leap, and a whole bunch of eyewear as well, and some interesting SDKs that try and solve some problems around getting geographical data in or image recognition, all sorts of stuff like that. The only thing that's not Unity-based here is the Snap glasses. Everything else runs on Unity. And once you've got past the basics of AR Kit and AR Core, have a look into new SDKs like 6D8i or 8th War to see what you can see where you can go with this. But for today, we're just going to talk about handheld AR, specifically AR Kit and AR Core. Now, let's think about what they can do, because we're going to go through some of these things today, and I'll explain how some of them works. But let's just set the scene first for when you've got AR Kit and AR Core, what sort of things do they offer? Well, I mean, the most obvious one is that they offer a camera background. When you're in an AR Kit or AR Core app, you can see the world through your camera. They offer motion tracking. So as you're moving your phone around in the real world, it's using image analysis to determine how your camera is moving. So in Unity, you can track your camera and do change your point of view and do various things with that. As we're moving our phone around the world, then there's these image processing algorithms that are trying to understand the world that we're looking at. And the first thing they do is they find interesting points in the world, corners of the desk or wood pattern on your table or things like that, and track those points, and those become point clouds. This gives us some understanding of the world. Lets us get the general shape of things, and it's the first thing we start with. We also get the opportunity to use reference points. Now, this is called other things in other SDKs, like world anchors. Anchors is a pretty common term. It's just points we can put in the world, and as we're looking at the world and using AR, those points stay where they are in the world. And if our world understanding changes, so if someone moves into the room or our image, our algorithms then detect something, then it will move that anchor and keep it up to date. Now, the slides are a bit fuzzy. What I'll do is I'll actually, at the end, I'll put a link for the slides as well, so you can download them and have them offline. And that way you can refresh your mind on that as well. I can see, looking at the screen now, that they're quite fuzzy. Okay, so what I'll do is maybe I'll just put those slides in now to so that people can follow along offline. Let me just quickly look those up. I'll just get that link right now. If you follow that link that I've just put in chat, then you can download those and you can follow along. I apologize, it is quite fuzzy. I'm not sure what's going on there. Maybe just an internet connection issue, but I'll charge on anyway. So I don't want to spend too long on this list. Just go through these features. There's image, object, and face tracking, which is some of the new AR Kit and AR Core features that have come in. And once we have this world understanding, we've placed anchors, we've got point clouds and planes down, what do we want to do? Well, we want to interact with things. And the main way we interact with things is ray casting. So you're probably familiar with this already if you've had some experience with Unity. But basically we can cast a ray from where our phone is into the world and see if we hit something. So that means we can see, gives us an opportunity to place something on a plane or to understand our world. Other AR Core and Kit features are color, temperature, and brightness, so we can try and match the brightness of the room we're in and the color temperature. And a new AR Kit feature recently is environmental probes, which lets you get extra lighting information from the world. And they and that way you can add some realism. I'll talk a lot about this later on as well, about adding realism to your scene. And then the last thing that's new that in AR Kit and AR Core is anchors, sessions, and spaces. So this whole idea, and this is a big topic all in itself, that I can recognize a room, I can go away and then I can go back and recognize the same room, and maybe the things I've placed in the room are still there. So for instance, if I've placed a character on my desk and I go away and I come back the next day, then I should be able to look at that same scene there and see the character that's still there. So that takes saving and it takes sessions. ARKit has some of these features. HoloLens is really great at this. It has a great spaces API that lets two people look at the same space and recognize it as the same space. Some of those SDKs I showed you before, like 6D, are really trying to aim to solve this problem of how can we recognize a place, like how can we fingerprint a room so we recognize it later on, and how can we save what we've done there so we can come back later on. So just a bit more detail on this. I've mentioned this already. AR anchors is a way we can place something in the world that has a position and an orientation, and this is going to be automatically updated as our world gets updated. This is just some visuals to show what I'm talking about here. Here is where we can find some planes. So when we find a flat area in our point cloud, we can call that a plane, and it means we can do things with that plane, place things on it, for instance. And as I mentioned, the other thing we want to do is for interaction, is we want to cast a ray from our camera into the world. And here we can see that we can use that to place a cube or to place a little Android robot and that sort of stuff as well. So that's our main way we interact with our world, is by doing raycast to query it. And lastly, a visual for light estimation as well. I'm not sure how these videos will come over on the low res screen, but in here we've seen that someone switches the light off in the office and the line can react to that, because we can get, in our code, we can get a light estimation there and change how we render things, but also then respond to that as well with different events. So ARKit and ARCore, we've had those SDKs for a while, and the thing is that they're quite similar, and so when people want to make an AR app, what they've had to do is they've had to implement both ARKit and ARCore. And so one of the things we really wanted to do was to provide a unified SDK for people to use, so they could write their code once and it will just going to work across the board in ARKit and ARCore, and also in future providers that come through as well, aiming to just have a general AR API that people can use. Now, so that's called AR Foundation. We did have an SDK earlier, an experimental SDK earlier on called that was our AR interface. That's not going to be updated anymore. We're all going to keep rolling with AR Foundation now. So what can AR Foundation do? It does a good part of what ARCore and ARKit does, but not everything just yet. It's a subset of those features. Because some of the things that ARKit does, ARCore doesn't do, and so we provided a uniform API that everyone can use right now. We will extend this later on, so I'll show you that later on. We'll go to our roadmap and show you when we're going to bring these sorts of things in as well. But these will come later on. But at the moment, what we have here is the camera background, of course, tracking our camera through space, point clouds, our reference points and planes, our color temperature, and we can interact with the world as well. I'll go into some more details of some of the extra utilities we've added for that, like the make content appear at function. So what I want to do here, one of the aims here is that I want to give you the idea of how you can create your own AR Foundation app. So I'm going to jump into Unity and show you how to make something from scratch. We'll go through all the steps of just getting a basic app where you can place a cube on a plane, and I'll go through the major components and explain what each of them do. Just going to tab over to Unity now. So here's Unity. Let me just quickly switch to the light skin because I think that's a little more visible. So what we have here is we have the standard Unity. Now, something that has been introduced in Unity 18.1 is a package manager. So before, if you've done any ARKit or any ARCore development in the past, you've probably gone to a website and downloaded a Unity package, or you've gone to GitHub and clone that repository. To make that easier for you to get and make it easier for us to update, we have this new window here called Package Manager. And when I open this up, we can see the packages that are already installed. And then we have a tab here called All, which is all the packages that are available to us. And I'm going to zoom in there because I know the resolution is not great, so you can see the packages I'm talking about. We have these packages here, AR Foundation. So AR Foundation is the one that you want. If you go up here, you'll have an install button. So I'm in the All AR Foundation install, and that's going to get you AR Foundation. But what that with AR Foundation, we don't assume what other SDKs you have installed. So you will want to go to AR Core and AR Kit and install those plugins as well. So in this project here, I've already done that just for the interest of time. I've got AR Foundation, AR Core, and AR Kit installed. That's all you need to do. So now when I go to my project window, in 18.1 you'll have a packages folder down here down the bottom. And in those packages, you can see there's AR Foundation, AR Core, and AR Kit. That means that all the code is there available for you. It's in the project already, so you can open up any of these and see what these are and play around and copy the code and modify it and do whatever you want with it. So this is a huge advantage. It's all open source, it's all there, and it means that when the AR Foundation team makes a bug fix, they can publish it straight away without having to, so you don't have to wait for a patch release of Unity or the next release of Unity. It's just, they can just release whenever they're ready. So that's packages and how to get the AR Foundation package and the AR Core and AR Kit plugins. That's our basic to get started. So I've got a blank scene here. How do we get something happening? So I'm going to right click in the hierarchy, and now we have this new XR folder here. So this is the create menu that lets me create objects and effects and all this kind of stuff. There's an XR section here. It has 4 items: the session origin, the session, and a default point cloud and a default plane. So I'm going to just first of all create an AR session. And that's put just one game object in my scene called AR session, and it has one component called AR session. So AR session is the component that determines the lifetime of your AR. So you can use this to stop and start your AR sessions. There's some options here on the side for turning on light estimation. So if you don't want that on, then we'll keep that unticked, and it just saves a little bit of time and processing power. The other checkbox here is attempt update. That's on by default. This is really useful. What this does is, when this app gets installed on someone's phone, if they don't have the latest AR Core SDK installed on their phone, it's going to update that for you. So it's going to, whenever you install the app, it's going to try and get the latest AR SDK on a phone and install it. So that's worth having on. So right now, AR session, that's going to automatically start our session when this app launches. So now I'm going to go on to the next one, which is AR session origin. So when I've created this, you can see that there's a little bit more has been created. I've got the AR session origin, and I've got an AR camera underneath. So why do we need an AR session origin? When we start our AR app on our phone, there's no sense of where we are in the world. So what we have is something called session space. This is when wherever you're holding your phone when you first start your AR app is the origin of your AR session world, and everything happens relative to that. So if in my scene here I put a cube and I placed it at the origin, it would be placed where the camera is when the AR app first starts. And so we use this as our reference point. It does a bunch of other things for us as well. This is the part we're going to use for raycasting. This is really the parent object that lets us do a bunch of stuff with our AR session. So underneath that we have an AR camera. Now this has got a couple of important components on it. It has a camera. So this is the camera that's actually going to render things in our scene. It's got this tracked pose driver. Now this is a really important component because this tracked pose driver is what you use for VR as well. If I drop down, look at some of this stuff here, I can control an XR device, a controller or a remote. So I can use this to track my Rift touch, my touch controllers, for instance, and track its position. I can track the head on my VR device. So this track pose driver is used quite a lot in the XR world. Here I'm going to use it for my XR device. So this is going to track where my mobile phone is in space. So if I ever want to know where something is when I'm in my AR app, I just have to look at this game object and its transform, and it's going to be where the camera is. And finally, I've got my AR camera background. So this is the thing that renders what my camera captures onto the back of my Unity scene. I can use a custom material here if I wanted to do something like a grayscale effect or some edge detection or something like that. But most of the time you'll just leave that as it is. So right now, we have AR session, which starts the session. We have an origin, which defines the space we're in, and an AR camera to render something. If I went and built this and put this on my phone, I would be able to see the camera view, and I'd have an AR session in place. So the slides go through this as well. So if you've got the slides, that will give you a bit of a reminder of what all these components are for. AR session is for lifecycle. AR session origin defines our AR space and lets us do raycasting and scaling and a whole bunch of other stuff. Track pose driver for tracking our phone, and the background for rendering that. By the way, there is we do have Jay online here as well. So if you have any questions as we're going, just type them in the chat, and we can answer you as we're going. You don't have to say them to the end. So now that we have our AR session up and running with our camera background, what we want to add now is we want to add some planes and some point clouds. Let's just start with the point cloud here. So in our XR menu, if I right click and go down to XR, we had a default point cloud and a default plane. So I'm going to click on the default point cloud. Now this, and what this has created here is actually created an object in my scene called default point cloud. It's got some components here. It's got the AR point cloud component and an AR point cloud particle visualizer and a particle system. So these three things. The AR point cloud defines the point cloud itself. So that's really this collection of points. And the particle visualizer is how we visualize that. There's a couple of different ways you can visualize a point cloud. The particle visualizer, what it does is it actually creates particles and just keeps them in the same spot as where the points are in the point cloud. That means that I can come down to this particle system, I can do things like change the size of it, change the color of it, and change some other things here to change the appearance of what the points look like. The other way you can visualize this is that we have an AR point cloud mesh visualizer, and what that does is visualize all the points as not as a mesh, but as in the vertices on a mesh. And you can use a shader to change the appearance of those points. So we have one point cloud here. We have to do a little bit of a dance here to get this to do what we want to do. What we want is I'm going to go to the AR session origin here, and I'm going to click on add component and type in AR point cloud. And as I type that in, you'll see a few different options here. We have the AR point cloud component itself. We have something called a manager. We have the two visualizers I talked about, the mesh visualizer and the particle visualizer. So I'm going to add the point cloud manager here. And this takes one parameter here, which is the point cloud prefab. Because what this does here is it listens for events from the AR subsystem, and whenever a new point cloud is detected or when a point cloud's changed, it will create a new point cloud from a prefab and update the existing point cloud. So this is really important, this step. This needs a prefab so it can create point clouds whenever it needs. I've got a game object here. So what I need to do here is drag this in down the bottom into my project view. I'm going to drop this into the prefabs folder. Or I missed, but it's down here. So I've made it into a prefab. So now I can delete this from the scene. Going back to the AR session origin, I can now drag this prefab I've just created here into the point cloud prefab section. And that's the setup that I need. So now if I was to build and run this application, once I started running, I'll get the camera background, but I'd also start to get a point cloud to appear around me as I looked around the room. So that's a great first step. And it's a very similar process for planes as well. So I'll just run you through the plane, how to do a plane as well. Going into my hierarchy here, right click. In the XR menu, I'm going to go to AR default plane. This creates a default plane here. It's got a bunch of different things on it. Let me show you the components. It's got the AR plane, which has some information about the plane itself. It has a visualizer here that's going to actually visualize the plane, because when the AR subsystem says I've detected a plane, all it does is give us the points on the plane it knows about. It doesn't actually give us any. It's up to us to visualize it how we'd like, and there's a bunch of different ways to do that. This one here generates a mesh on the fly. It's got a collider. You could remove this or disable it if you don't need a collider. And it's got a mesh renderer. This is how we can see the mesh itself. So it's got a default material attached. You can change this material however you'd like, to put some grass down or a transparent plane or however you'd like your plane to appear. This is the material you'd change. And it's got a line renderer. This is optional as well. You can turn this off. This draws a line around the outside of the plane to give it a solid boundary. So same step here. I'm going to turn this into a prefab by dragging it down into my assets, into my project view, delete it from the scene, AR session origin. I'm going to click on add component. I'm going to type in AR plane manager. So again, the plane manager is something that's going to, whenever it detects a plane, whenever the AR system detects a plane, it's going to call into here and it's going to create this prefab for us. And it will also, if the plane change, update the prefab in here as well. So there we go. So we have, if I built and run this now, we would have a point clouds appearing, and we'll also have planes appearing wherever we moved our phone around. So I suppose this is the base setup. This is what you'd start with when you started any AR app, and we do have some samples that have basically this set up in here as well. I'll give you a link to that later on. So just to reiterate this, a point cloud has these 4 components. Our point cloud manager creates point clouds. Our point cloud component has information about the point clouds, and then we have 2 types of visualizers. And so for the plane, we have similar sort of thing. We have an AR plane, a manager, and a visualizer as well. Now we've got this basic setup here. I think most of the time we want to look at point clouds in some way, and we want to see planes in some way. How do we actually add some interaction to this? How do we make this actually do something? So what I've got here is I've got a script. This is a script out of our samples. Our samples are pretty basic at the moment. They've just got this one demo. This is called place on plane. I'm just going to open this up so we can have a look at it. So we have this class here, place on plane. I'm not going to go in detail through what it does, but I'll come down here and I'm going to zoom in here so it's super visible what's going on. Here we have our update loop. So what we're going to do here is if someone's touching the screen, then we're going to grab our session origin. Remember, session origin is the base of our AR space. It's really the thing that knows where things are positioned. We're going to do a raycast with that position. And there's various filters we can do with this. Notice this is not a physics raycast, this is a raycast just for AR. So here I can say, hey, I just want to hit planes that have if you hit the plane within its defining polygon. There's a number of different options here. I can try and hit point clouds as well. But here I just want to be able to place it on the plane. If I hit something, then what I'm going to do is, if I haven't spawned anything yet, I'm going to instantiate a new prefab. But if I have already instantiated something, then I'm just going to move that to wherever the hit is. So this is the a basic way you can tap on the screen, and it's going to play. And if you've tapped on a plane, it's just going to place an object at that point. This is, the way you add interactivity to your AR app. So that's AR Session Origin Raycast. So that's the demo part. So this is the basis for you to get started in your AR app building. You have a way to find things within the scene. You have a way to place planes and point clouds. One thing that you may run into is as you start to make things, what's going to happen is you might want to bring in a particle system or do some physics or do some sort of things. And Unity really, for all these sorts of systems, assumes that 1 meter in the world, 1 unit in Unity is 1 meter in the world. So and often in AR, you want things to be quite small. So if I wanted to place a whole town on my table, I'd have to scale that down, and it might mean that physics or my navigation system don't work as I expect them to. So what I'd like to do instead is to keep things at the same scale, but change what the camera sees. I'll explain this a little bit here. This is taken from a blog post explaining the scale situation, and I'll provide a link to this as well so you can check it out. But if I was just to scale the session origin, you can see here if I have a cube in my scene, that cube's not necessarily going to scale along with it as well. So how can I solve this? And this is what it looks like if you're looking at it from the game. It just looks like the cube's floating up and down as I change the scale. The blue plane stays the same size relative to the camera. This is important. But the cube is moving in seemingly randomly. So what we have is in a session origin, we have a function called make content appear at. And what this does is it actually moves your session origin to the center of your scene and offsets the camera. Now this is a bit mind-bendy, and maybe it's not completely necessary to understand how it works. But what it does is it gives this effect here of now as I move the session origin around, it appears like this island is moving, whereas really it's the whole session around it that's moving. And that means I can run particles and do whatever I want on the island, and things behave as expected. So if you have some code here, you might want to be calling make content appear at, and your position will behave correctly, your scaling will behave correctly now as well. So as we scale the session origin, you can see that the island's in the correct spot, and it also rotates correctly. And the really nice thing about this also is you can mark all your objects as static because they don't actually move, and you're just moving everything around that. And this is one way you can handle scale. So I emphasize this is only really important if you're running physics or particles or things that require things not to be scaled down really small. But session origin make content appear at is one solution for that. So what's going to happen next? We have this base functionality in. What's going to be next? Well, we're going to get some things that are some helpful debugging things. At the moment, what happens is when I make a change, there's really no way for me to run it inside Unity. I have to make a build to my phone and run it and see if there's something wrong. And if there is, I need to fix it up and then make another build, which often takes a couple of minutes. So we will have tools for running things within your editor and simulating within the editor, so you can test things out in the editor. And we will also be releasing remoting. So this means you'll be able to launch an app on your phone and watch the results inside your editor. And so you'll get a camera feed, you'll get the phone movement, but that just gets fed back to the editor to be simulated there. We'll bring in image and object tracking and face tracking as well. So we'll start to fill in some of the gaps that AR Core and AR Kit have, but aren't uniform across all the SDKs. So the only time frame I have for this is by the end of the year, as I was asking the team about this. So sometime this year, these things will drop into place. Another really exciting development here is Mars. So one thing that we know when we're making AR experiences that's tricky is you have to deal with the real world. So it's quite easy when I'm making a game. When I design something in the editor, that's what it's going to be like when I play it. But when I'm using AR, I'm doing all this point clouds and plane finding, and so I might have a table in front of me and someone else might have something completely different, a bench top or nothing at all. They might be on the train. So what we want to do is give you tools within Unity that let you simulate different environments and author specifically for AR and a different mode of being. So one thing you can see here in I'm going to zoom in as well for resolution's sake, is we have two windows open here. I have my usual scene window here, and I also have a simulation window. So this is the things I've authored. I can see how they're going to respond to different environments. And I actually have a little bit of a video here. Let's see how this goes with the bad resolution. But we can see on the left here we have the simulation, which is an office. It looks surprisingly similar to the Unity San Francisco office. And on the right we have the scene. So I have just these AR entities on the right, and they behave and fit on different things based on rules I've set up when I go into different environments. So this grass might look for a table to sit on, for instance, and the rocks might be on a table that's above a certain height. And I can define different ways I want these things to behave in different environments. So this is an authoring tool specifically designed for AR. And here again we have now we have the app running, and we can see that I've got a grass environment. This is the Unity San Francisco office, by the way, and we've got this girl who comes here, and it's found planes where the tables are, and she can run around. And even though when I've authored this I don't know where these two tables are, there's enough smarts here for her to jump and run between these two services. So this is something to look out for, and it's definitely still in the preview stage at the moment, but it's something we're looking forward to in the future to make AR authoring easier. And here's the face tracking as well. Face tracking will be part of this. Again, a simulation and a scene view. Just want to talk briefly about authoring as well, because AR is a really different platform to author for. And so some of the things that you need to think about when you're making these sorts of apps. Obviously there's a lot to talk about here, so I'm just going to touch quickly on a few different points. The first one is expectations. It's likely when you're making your AR app, you're in a nice brightly lit room or office, and you're going to have this iteration of making something, trying it out on your table, and you'll probably be in the same spot every time. And you might think your AR app is going to look like this, where you've got a bunch of happy people around, a really nice well-lit environment, and everything's going to work as you expected. But the reality is people are probably on their train ride home when they hear about your app, or they're in a dark environment, or there's some way that they can't use your app in the way that you'd expect it to. So two strategies for that, to avoid becoming part of the pile of shame, is here's the New York Times app. It has AR embedded. So if I'm on the train, I can still read a news article, but if I have some clear space around me, I can go in and view an AR mode here as well. So this is the one thing of just treating AR as a function of your app that can be used optionally. Your app still has some use outside of that, so that people can use it whenever they want and use AR when the context fits. Another idea is that you want to signal what space is required when you're making an AR app. So this is called Enter the Room. This is put up by the Red Cross. It's really worth looking at this app. It gives you an experience of what it might be like to be a refugee or in a war zone. Now you actually have to walk inside a room, so you need a lot of space for this. And so here they've given you like a ghost of a room, so you can see what space I'm going to require. So if I'm on the train or I'm somewhere, before I go through setting everything up, I want to know, hey, do I have the space for this? And this is a great way to kind of foretell what's going to happen. And again, this idea of you'll be in an office making your AR app and you know exactly what to do. If anyone's made a game, then they've showed it to someone in the public, they're like, don't press that, don't do that. This is AR's the same. First thing people are going to do is be looking in the spot you don't expect them to. So one thing you want to do is handle errors, and you can get callbacks when tracking's lost, when there's low light, and you can get reasons for that, and you want to feed that back to the user. But I really recommend creating a fiction around your experience that gives a way to explain that rather than using jargon. People don't know what planes and point clouds are, so give them a different reason. Here's an app I worked on a while ago, where we came up with the idea of you're trying to land a monkey. So if there's a table there with a good plane on it, it's going to say good landing spot. If you're looking at somewhere that's no good, it's going to tell you, hey, I can't see anything to land on. Now this is probably easier in a game than another app, but in any app you can probably find a reason why it's not a good spot and give people some feedback for what they can do to improve that situation. Another thing is in AR, it's really easy to make it look like your virtual objects are just floating on your screen and not attached to anything. So there's a whole bunch of techniques for making it look like the real and the virtual worlds have come together. Probably the simplest one for that is just adding shadows. So this is the IKEA Place app, and we've got a chair here, and we can see the chair as a shadow underneath. And even though it's not a very accurate shadow, it still helps the chair feel like it's part of the environment. And this one here, it's just a projector that's projecting down as a cheap blob shadow. You can go to the AR Core and AR Kit repositories and find a whole bunch of useful materials and shaders there for doing things like real-time shadows and occlusion. And I really recommend you going there and downloading them. But often something simple like this drop shadow is enough to make it believe that this chair is actually in the world. This is another AR game I worked on, and we decided to leave skid marks. So anytime something interacts with the environment, it's good to leave something behind to show you that it's had an effect. This is part of affordances and feedback as well, so you know that you're doing the right thing. But it does make it more believable, make this car more believable. This one here is a HoloLens app. I love this one because you blast a hole in the wall and it's got a completely virtual world behind, but you really get really great parallaxing, and you really believe that that world really exists behind the wall because it's embedded. So if you have a chance to embed an object in a plane or embed an object in a world like this, then go for it. Have some dirt kick up around where something comes out of the table, for instance, is a great way to make people believe that these things are one. The virtual and the real world are one and the same. And this is another thing that I made where I've just taken some lighting information. I've just used the camera feed to create some reflections and lighting on this robot as it walks by. And so again, it just helps you believe that this robot is really there and walking past that boy with the red jacket, because you can see the red reflected on it. So always look for opportunities with physics and rendering and audio to show when the real and the virtual world bump up against each other. So there was a question about, can all phones be used with AR Foundation? So AR Foundation at the moment is just AR Kit and AR Core. So any phone that's supported by those two, you can use with AR Foundation. There's no differences there. So for for AR Kit, that's all the latest iOS devices. For AR Core, that list is getting longer every day. Actually, I think Chromebooks was just added last week. So it's worth just checking that list to see what phones and tablets are supported. So here are some resources for you to continue on with. This is probably going to be quite hard to read, so grab the slides at the start and grab these links. The main ones are, there's a blog post when we announced AR Foundation that has some details that are worth looking at. The manual, gives you some really great, more technical details on the components I've talked about and what they can do. We have some AR samples. The AR samples really is at the level of what I've showed you tonight. You can place a box, but at least it gives you a starting point and gives you the session set up and have everything set up quickly for you. And it gives you that code to start with. There's a post on our forums from one of the developers, Tim Maurer, who talks about scaling in more detail and about why we have this make content appear at and how to scale things if you need to. And the last two links are the source code repositories for ARKit and ARCore, and this is where you can grab some handy shaders and materials for doing shadows and occlusion. There's nothing specific about those shaders between ARKit and ARCore, and you can definitely go and pull those in and use those in AR Foundation as well. So I'll just give you some ideas for how to extend beyond that. And that's it. So thanks very much. I'm going to hang around for 5 or 10 minutes to answer questions. So feel free to put those in chat. I'll put a recording of the session up as well, so you can review